The inverse of a function. Consider the following. We have a domain x and the range y. And our function operates on each element of the domain to produce the corresponding element in the range. So that's the action of f of x. The inverse of a function undoes that action and takes us back from each element in the range to a corresponding element in the domain. The notation that we use for the inverse of a function is f to the minus 1 of x. Not every function has an inverse. A function will only have an inverse if for each element in the range, the set y, we have one and only one element in the set x. This is called a one-to-one correspondence. Here we see examples of two functions. F of x equals the square root of x and g of x equals x squared. Now, this function has a one-to-one correspondence, and so we'll be able to find the inverse of the function, because for each value in the range we have one and only one value in the domain. For this function, however, there is no one-to-one correspondence. You can see that the value 4 in the range has two values in the domain. Here are graphs of the two functions we looked at in the previous slide. The graph of y equals the square root of x and the graph of y equals x squared. Now, we said that this function will have an inverse, but this one won't. An easy way of finding out whether a function has an inverse is to draw the graph of that function if at all possible, and then to draw a horizontal line at any point on that graph. If we can draw a horizontal line through the graph at only one point, that means the function has an inverse. And we can draw the line at any point on that graph and we'll only have one point of intersection. Now, if we do the same thing with the second graph, the graph of y equals x squared, you can see, I hope, that graph, that line meets the graph at 2 points. So this graph represents a function with a one-to-one correspondence, and so we can find the inverse of the function. This graph represents a function which does not have a one-to-one correspondence. The steps for finding the formula for the inverse of a function are: 1. Change f of x or g of x to y. 2. Make x the subject of the formula. Change y to x and x to f to the minus 1 of x. First example, something nice and simple. F of x equals 3x plus 4. We change f of x to y. We want to make x the subject, so y minus 4 equals 3x, and then x equals y minus 4 over 3. So we change x to f to the minus 1, and we change y to x. Now, the domain of our function, there are no restrictions on the domain, and similarly there are no restrictions on the domain of the inverse function. Here's a second example. F of x equals 2 over x minus 4. What we might see is x is not equal to 4, which is to say x can have any value. X is a member of the set of real numbers, but x cannot equal 4. When x equals 4, the bottom line is 0 and the function is undefined. So change y change f of x to y. Now what we're going to do is to multiply both sides by x minus 4, get rid of the fraction, expand the bracket, we want to make x the subject. Finally divide by y. Now we could leave it like that. We do of course have to change, so x becomes f to the minus 1 of x and y becomes x. So we could leave it as 2 plus 4x over x, or we could write it as 2 over x plus 4. But you will notice that we have an x on the bottom. So if we were to state the range, x is going to be a member of the set of real numbers, but x cannot equal 0. Example 3, you'll notice that we have an x on top and an x on bottom. How does that change things? Well, let's see, y equals x over x plus 2. So y lots of x plus 2 equals x. Expand the bracket. Now, we want x to be the subject. What we have to do is to bring both x terms together and remove the 2y. So yx minus x equals minus 2y. How do we get one x value where previously we had 2? We're going to take out x as a common factor. And finally, divide by y minus 1. Now there's something I can do here to tidy things up. We have a negative here, which is not exactly untidy, but we can deal with that. If I multiply top and bottom by negative 1, I have 2y on top and 1 minus y on the bottom. The effect of multiplying the bottom by minus 1 is simply to reverse the terms. Last thing to do, change x to f to the minus 1 of x and y to x. And we might also state the restriction on the domain. The graph of the inverse function. Here we have some function. And what we want to do is to graph the inverse of the function. Well, first thing to do is to draw the line y equals x, and to reflect this graph here in this line here. It doesn't need to be exact, so we have something that looks like that, and that would be the graph of y equals f to the minus 1 of x. We could perhaps put some coordinates on the diagram to make it a bit easier. Say that was x equals 5 and y equals minus 2. So this would become x equals minus 2 and y equals